You know that super bright, beautiful screen on your smartwatch? The one you look at a dozen, maybe 100 times a day? But have you ever stopped to think about what's actually going on behind the glass to make it so sharp and so efficient? Well, today we're going to dive into the tiny, powerful chip that makes it all happen. I mean, really think about it. What does it take to power millions of tiny pixels on a device that small and somehow keep the battery from dying in just a few hours? It seems kind of impossible, right? Well, the answer lies in this incredibly sophisticated, tiny piece of technology called a display driver. Okay, so to really get what this driver is all about, we've got to talk about the company that actually makes it. And we're talking about a huge player in the display technology game, a company called Chipone. So, Chipone Technology. They've been around since 2008, and they're one of the world's leading companies for designing these kinds of display chips. Their mission is right there in their motto, to be a leading company of total display control. You can think of them as the architects behind the scenes, the ones who make all our screens pop. And listen, they've been at this for a long time. We're talking 17 years. And for all that time, their one and only focus has been this super complex world of display chips. That's almost 2 decades of specialized, hardcore experience packed into every single thing they make. So you might be asking, okay, but how innovative are they? Well, this number says it all. Over 2,500 patent applications. Just think about that. This isn't just some company churning out parts. This is a serious R&D powerhouse. They're the ones constantly pushing the envelope of what display tech can even do. All right, and all that expertise, all that innovation, it brings us right to the hero of our story today, a specific chip called the CO5300. And trust me, this is where the real magic happens, especially for our wearables. So let's back up for a second. What even is an OLED display driver? The easiest way to think about it is like it's the visual cortex for your device. It's the translator. It takes all those digital ones and zeros that the main processor is sending out, and it translates them into these super precise electrical signals. And those signals are what tell every single tiny pixel exactly what color to be and how bright to be, and it does this thousands of times every second. It's nuts. And here it is, the CO5300. This little guy is designed as a complete single-chip solution made specifically for AMOLED displays. You know, the kind you see in all the best wearables. It's basically an all-in-one powerhouse. What's really mind-blowing is just how much they've crammed into this one tiny component. I mean, it's not just a driver. It has its own RAM right on board. It has a built-in timing controller to make sure everything is perfectly in sync. It even has its own power supply circuit. This crazy level of integration, that's the secret sauce. That's what lets us make our gadgets smaller, thinner, and way more power efficient. Okay, so we get it. It's a compact, all-in-one deal. But now let's get into the really cool stuff. Its superpowers. We're talking about how it handles power, color, and precision to give us that jaw-dropping visual experience. Okay, check this out. This is one of its cleverest tricks. When you're actively using your watch, swiping around, it's in normal mode, and it's blasting out a full 16.7 million colors. It's gorgeous. But the second it goes to that always-on display, it flicks over to the super low-power idle mode that only uses 8 colors. That is so smart, because you can still see the time at a glance, but it's barely sipping any power. It's all about saving that precious battery life. Then there's this other feature called automatic current limiting, or ACL for short. Just think of it as a super intelligent brightness manager. And the benefit here is a double whammy. First, it slashes power consumption, which means longer battery life for you. And second, it actually protects the OLED screen itself, so the display stays vibrant and healthy for way longer. And color accuracy? Oh yeah, they thought of that too. This chip gets incredibly granular. It allows for individual gamma correction for every single red, green, and blue subpixel. This is like giving the manufacturer a set of precision tools to tune the display to absolute perfection. The result for us? Colors that are just spot on, vibrant, and totally lifelike. So let's put it all together. You've got amazing power efficiency, brilliant colors, and pinpoint precision. Now let's connect the dots and see exactly why this all combines to make the perfect chip for the gadgets we wear on our wrists every single day. And hey, you don't have to take my word for it. The official datasheet for this LSI, which just means large-scale integrated circuit, by the way, it says it loud and clear. This component was designed from the ground up for one main purpose: wearable devices. It's literally built for this. Let's just trace the path on one more feature, just to see how it works. Okay, so the technical feature is called Deep Standby Mode. The benefit of that feature? super, super low power consumption when the screen is off. And the real-world result for you and me? Simple. A smartwatch battery that lasts longer. That's the whole point, right? Now, the CO5300 is obviously perfect for wearables, but it's really important to know that this expertise doesn't just live in a bubble. Chipone is applying the same kind of tech across the entire display world. We're talking about the phone in your pocket, the laptop on your desk, the big TV in your living room, and even the futuristic displays in cars and VR headsets. So, at the end of the day, what does this all mean? Well, the next time you just casually glance at your wrist to check a notification, maybe take a second to remember all the complex, totally invisible tech packed in there, like the CO5300. It really is a tiny marvel of engineering, working nonstop behind the scenes just to power your view. And that really leaves us with a huge question for the future, doesn't it? Our devices are only going to get smarter and smaller, and they're going to demand way more graphical power in an even tinier space. So, what kind of breakthroughs will the next generation of these little drivers have to pull off? What amazing new things are they going to unlock for us next?